Your homework. 29 and 27. We'll do 27 first since it comes first. 27. The region enclosed by the triangle with vertices uh, 1, 0, 2, 1. Don't say that. And 1, 1. Oh, that's not 1, 0. That's 0, 1. Oh, okay. Here we go. Let me use the lines on here. Okay. 1, 0, 2, 1, and 1, 1. Ooh, it looks like it's going to have a hole. I am rotating that about the y-axis. Are y'all with me? Okay. So from the y-axis, I'm going from here across, right? So the radius of my hole, this is literally how I did them. I did everyone on my circuit like this. The radius of the hole. So to get to the y-axis, well, I need to know what this line is, right? In terms of y, not x. So what is the equation of that line? Y equals x comes through the origin and does this. Plus 1 would be here. It's minus 1. But I can't do it. I've got to have it in terms of y, right? Because I'm with respect to y because I'm going around the y-axis. So what is the whole radius? W whole. If I solve this for x, if I add 1 to both sides. If I'm going about a vertical axis, I'm in terms of y. If I'm going about a horizontal axis, I'm in terms of x. Are y'all okay? Okay, from my axis of rotation, which is the y-axis, all the way across, right? Now, because I'm doing this vertical rotation, I've got to be in terms of y, not in terms of x. If I was rotating about the x, that would be okay to leave it like this, but it's not. I'm rotating about the y. So I just changed it and solved it for the other variable. If you're doing a vertical rotation, it needs to be solved for x. If you're doing a horizontal rotation, it needs to be solved for y. I wrote the equation based on these 2 points. So what's the equation of the line that goes through the point 1, 0 and 2, 1? Yeah, but why those? Why not? I thought we were planning horizontal. We are. The horizontal what? We're finding the distance here, right? The distance from here up is x minus 1. But the distance from here across, I solve it for y or for x, and it's y plus 1. This distance is y plus 1. You see what I'm saying? I'm solving it for the other variable now. Are y'all okay? A little bit. Okay. What is the radius of the hole with an H? As you rotate around, if that triangle is coming around like this, like a carousel, what is the hole? Where is there no shape? Always from the y-axis, right there, right? And it is constant. Do you agree? There's a constant hole. So this has kind of got the edges dipping out as it comes around, right? But that hole in the middle is constant. What is that constant hole in the middle? That's the all the way across. It's just one. This is a cross. This is 1. This is 2. This is a length of 1. Because it's a diagonal line, it's not a straight vertical line. So it changes. It's because it's only 2 at the very top. So here it's 2, but here, well, it depends on what x is. Wherever I am on x, that depends on my value there. It varies is why. So I have to have a variable. Once you get the radii, the rest should be fairly easy for you. That's the hardest part to get, in my opinion. Then I come and I say, okay, well, the area of the hole then is pi r squared, right? So pi times 1 plus y squared. The area of the little hole, pi r squared. So it's always, now remember this is with respect to y. It's the integral, you got to do your bounds here. And I'm talking about y. So I'm going from 0 to what? The 1 because I'm y. I've got the pi outside because I'm taking it out of everybody. It's whole minus whole. So it's 1 plus y squared minus 1 dy. If it's rotating about a vertical axis, it's with respect to y. If it's rotating about a horizontal axis, it's with respect to x. Now this should be downhill for you. It has to be solved for y with respect to x. That's a normal one, where you just rotate it this way. So I would use x minus 1. I'm going to go ahead and FOIL this out. So it's 1 plus 2y plus y squared. Oops. Minus 1. The 1's cancel. I have pi. Oops, I'm going from 0 to 1. From 0 to 1. The nice thing about these is most of them have a 0 as an inbound, which most of the time means you only have to do 1. Antiderivative, 1/3 y cubed plus y squared. If y'all are struggling with this, do not wait until Thursday night to do your circuit. You finished with this circuit, you will be a pro at revolutions, I promise. Did you? You must have got that off my website last year. Well, Canvas last year. 4/3 pi. You have to find the radii. You have to draw a picture and you have to find the radii. Give me another one here. 29. We did 27. All right, pay attention so that you understand this is a lot like the circuit problems. The region in the first quadrant, Not for this one. I thought I let those out. Okay. The region in the first quadrant bounded above by the parabola y equals x squared. Below by the x-axis and above on the right by the line x equals 2. This is x equals 2. I'm going to go ahead and find this point. What point would those two intersect? At the point 2, 4. Right. So this is the area that I am looking for. All right. Revolve it about the y-axis. It is different than if you revolve it about the x-axis, about the y-axis. So this is a vertical rotation, and vertical rotation means in terms of instead of x. So my first question is, do I have a hole or no? How do you know? Because I'm rotating vertically, if I go straight across, right, I end up with a hole. Does that make sense? Girls, y'all got this? Because this is exactly like those. So if you struggle with those, you need to pay attention to this. All right. Do you see where the hole is? The hole is occurring because my radius is slicing through something with no shading on it, right? Nope. Nope. Give me the radius of the whole thing, including the hole. All the way across. Just 2. From here to here, that is 2 units all day long. It's constant because there's a vertical line there, okay? What about the radius of the hole? From here to here is x squared. Are y'all okay? That's the hardest part. Because now the area of the hole and the area of the little hole. Oh, it is. I'm sorry. This is a one. You're right. You're right. You're right. You're right. What should this be? Square root y. Square root y. That was a good catch, though. Thank you. Area of the hole is 4 pi. Area of the hole is from what to what? No. Why? 4 minus y. Y. Now it's easy. Yes. 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 So pi, is this what you got to start with? Okay. So 4y minus 1/2 y squared from 0 to 4. 16 1/2 times 16. No, they got 8 pi for 29. This is 29. Okay, 21 is rotated about the line x equals 2, but I will work that one with you because it's a lot different. But this is 29. 21 takes this exact same, but it rotates it instead about this line right here. So instead of rotating it around the y-axis, it rotates it around that line, and there's no hole. Okay, let me show you. All right, is this one good? Are y'all okay here? Yes? Okay. So let's look at 21. Your circuit goes through rotating you all kinds of crazy lines. Okay, so you have to understand, if you don't have the picture with the correct radius, that's where you just really start messing up. Or you don't write it in terms of a variable like I did. All right, pictures are key here. This is y equals x squared or x equals square root of y, depending on how I need to solve this one. Y equals 0, which is a horizontal line. X equals, bless you, x equals 2. Here's my shaded region. But it says revolve it about the line, x equals 2. It's still a vertical revolution, right? So I need to know.
You don't need the radius.
That's right, because there is no h hole. Do you see that? If I rotate it about this line, it's just going around, right? There's never, to find the radius, there's never a hole. It's just a W hole. But, yes, but that's not my radius. The square root of y, there you go, Ren. It's not the whole, it's not a, it is, okay. Okay. Okay, look, this distance is not square root of y.
Okay, it'll be the longer all the way across.
To find it, it's measured from the y-axis, right? This distance is square root of y. That's square root of y. Because it doesn't, not all the way here. Then this distance is 2. I need this little distance. Right.
That makes a lot of sense.
So it's 2 minus square root of y for the radius. You have to be able to identify the radius. That's the key. Because from there it's downhill. Area is pi r squared. Do you see why this one doesn't have a hole, like a H hole? If there is no white space on your line of revolution, because I shaded the other, the area then is pi times 2 minus the square root of y squared. That's the whole thing. So now I integrate. Okay, so this is the square root of y. Anywhere I go from here to that line is the square root of y. Okay. I need to know this distance right here, and that I don't know. So to find that, I know that there's this vertical line, and I know x equals 2 there. So I know I went over 2 to get there. So I know the whole thing is 2. So if I take 2 and subtract out this, then every time I'll just be left with that little piece of shaded area. It always helps me to draw my radii in. Remember, you can revolve around anything, but you're measured from the y-axis or the x-axis when you're trying to find it. Yes. Right, that is correct. Right. So now my volume, the integral. What am I going from?
From 0 to 2. No, you can't do that. It'd be x squared.
Which is, I'm in terms of y. I have to stay in terms of y. Yes. Yep. And it gets quite confusing. I forgot to throw my pi out there, but let me throw it out there. I'm going to go ahead and FOIL this out. So that would be 4. No, Dylan.
4 minus 2. 4 minus y. That's what I got. Yeah. I got that. So what?
Yo, Dylan, bro. What the heck? You got to FOIL it out. All right. All right, antiderivative 4y minus. All right, here's where it gets sticky. I swear I think this one is on your circuit. Or if this one's not on your circuit, this one very, very similar. Because I remember doing 4 times 2/3 y to the 3/2. 1/2 y squared. So your circuit's no calculator other than about 3 or 4 of them. I worked the whole thing without a calculator. It is. All right, so I have pi times, ask me again, no, I'm sorry. Yep. So I got 4 minus 2 root y minus 2 root y plus y. This is 8/3 times. I definitely remember these numbers. The square root of 4 is 2, and 2 to the 3rd is 8. Not a cube, it's square root cubed. So the exponent of 3/2 means the square root to the 3rd power. This is when it gets fun. 16 minus 64/3 plus 8. What's 24 times 3? 12, there's 72, and I'm going to subtract 64 from it, and it leaves me with what? 8/3. You will see this over here on the side on like every single one of my circuits. Because it's the y, these intersect at the point 2, 4, and because it's in terms of y, I have to take the y and not the y. What? The circuit? It took me, solid working through, it took me about an hour. Maybe an hour and 20. No, because we have a review too. No, because we haven't, that's just 7-3. That's not 7-1 and 7-2. We're going to review a little bit like that. No, I didn't give you 35. Yeah, because that's, yeah, no. Yeah, I swear I took it back off. Okay, don't worry about 35. Sorry. Don't worry about 35. What else? 50 what? Hold on. 50 what? 57. Ooh. This goes something like that. Not really, but
I can run it through that entrance
what?
hallway. Like somebody opens the door and I'll just run it all the way down out the parking lot.
So am I just supposed to do like an interval? So like from here to here?
No, you're rotating about
That.
the x-axis.
So
Oh, yeah.
So can I do from like 1 to 4? Or do I have to do
maybe
1 to 6?
minus 0 to 1.
No, 1 to 4.
1 to 4?
There's, yeah, but it's not a hole when you rotate. This is solid. You don't have to subtract anything out. So you just go from here to here.
So 1 to 6. That's what I did.
All right. I'm rotating here about the x-axis. So I need a radius. There's no hole.
You're rotating about which axis?
The x. So the area would be pi times all of that squared, right? Now if I square all of this, I end up with x squared over 144 times 36 minus x squared, right? And I'm doing this because I'm going to have to integrate in just a second. Oh, wait a minute. I did. Why did I distribute the square? It was multiplying instead of adding or subtracting. Adding or subtracting with the squared makes you FOIL. Multiplying inside, though, I can distribute. All right, I'm going to clean this up just a little bit. I've got the pi out here, but this is 36x squared over 144, and I'll clean it in just a minute, minus x to the fourth over 144. Right? I can divide both of these by 12, actually maybe even bigger. There'll be 3 over 12, which would be 1/4. So divide them both by 36. So I've got pi times x squared over 4 minus x to the fourth over 144. I did that because as I integrate here, the volume, I'm going from what to what? 0 to 6. I'm going to put this pi out here. And I've got 1/4 x squared minus 1 over 44, 1 over 144, x to the fourth. Gross. This is going to be 1/12 x cubed minus, what's 144 times 5? Thank you. 1 over 720 x to the fifth. I'm going from 0 to 6. You definitely need your calculator here. I plug that 6 in. I know 6 to the third is 216. No. Minus, I don't know 6 to the fifth.
I'm gonna guess about 16.
What is it?
I'm talking about 216.
Now do those on your calculator and do math, enter, free fraction. You should get 36 over 5, I hope. Is that what you got? 36 over 5. Are you sure? Y'all take doing. L'Hopital's is used when we are evaluating a limit. Indeterminate forms. For example, infinity over infinity, 0 over 0. When you do a substitution, okay, so if this happens, a limit substitution, remember we're talking about limits here. Well, limits we try to plug in if we can. So for example, if I had the limit as x approaches 0 of the square root of 1 plus x minus 1 over x. The problem with plugging this in is if I plug in 0, I get 0 over 0, right? Because 1 plus, bless you, 1 plus 0 is 1. The square root of 1 is 1. 1 minus 1 is 0. I end up in this form. So L'Hopital says if you get in that form, then take the derivative of both the top and the bottom and do it again. Then evaluate the limit. You're going to be surprised how confused you start getting as you go back to derivatives on what's derivatives and what's antiderivatives. So let's think about this. What is the derivative of this? That's the derivative of the top. Agree or disagree? What's the derivative of the bottom? Can you use substitution now? Yes. In fact, if I use substitution now, I get 1/2 times 1 plus 0. One half.
We take the top door